Hi, this is Dan Buller, retired electronics engineer, sitting on the front deck of my houseboat again. It's a Saturday, so we'll probably see some fishermen running back and forth. Real quick, I want to tell you about this really cool thing I just discovered. I was poking around the web and I found on All About Circuits, not All About Circus, All About Circuits. On All About Circuits, somebody was asking about the spectrum of a square wave when you vary the duty cycle. And this guy popped up and said, yes, if you have a 25% duty cycle square wave, then the 4th harmonic and the 8th harmonic and the 12th harmonic and the 16th harmonic are 0. I couldn't believe somebody would make that statement, right? So I went and tested it. And how did I test it? Because I don't have Excel anymore. I used the cool thing that I got from David L. Wilson. Use that formula in numbers on my Mac. Boom, nailed it. He nailed it. He nailed it. So it's true. So if you have a square wave that's 20% duty cycle, then the 5th harmonic, that is the reciprocal of the duty cycle, the 5th harmonic and the 10th and the 15th and the 20th will be 0. Okay, it's really cool. So if you have a 75%, and this is the cool thing, Law 6. Law 6 applies to square waves. So if you have a 75% duty cycle square wave, guess which harmonic gets zeroed out? It's the 4th, because it's the same spectrum as a 25% duty cycle square wave. So if you have 25% duty cycle square wave or 75% duty cycle square wave, the spectrum is identical. And so with a 75% duty cycle square wave, then the 4th harmonic is 0, and the 8th harmonic is 0, and the 12th harmonic is 0, and the 16th harmonic is 0. If you have a 10% duty cycle square wave, then the 10th harmonic is 0, and the 20th harmonic is 0, and the 30th harmonic is 0. If you have a 90% duty cycle square wave, then the 10th harmonic is 0, and the 20th harmonic is 0, and the 30th harmonic is 0. It's a really cool thing. Now, I won't say it's a coincidence, but it's kind of convenient. And so it's a good way to estimate if you're doing an interview and somebody asks you a question like that on an interview, you can nail it. You don't have to do the FFT in your head, which is really helpful. It's really great. And it's not really helpful for figuring stuff out for like the 26% harmonic. That's not really going to help you. What's 1 over 26? Oh no. For some of those easy numbers, it really is a nice ballpark number. So you can figure out what these things are like on an interview or something like that. So it's pretty cool. And I did want to mention this other thing I found on All About Circuits. On All About Circuits, what was saying that they were asking about the square wave and various things, and they said not only is it valid, but it can be proven on SPICE. Like, you know what I think about SPICE. SPICE is completely inaccurate because they use single precision math. They use single precision numbers. So that might not be a big deal when you're multiplying resistance times capacitance. But if you do an FFT, you're multiplying and dividing and multiplying and adding, and you're doing all kinds of crazy stuff. So you're going to run into some resolution issues. And I've shown you that. When you use SPICE, you can't get the numbers 0, 90, 180, and 270 for the phases of the harmonics. Everybody assumes that they're 0, 90, 180, and 270, but they can't prove it in SPICE because SPICE rounds things down in 32-bit math. So there you go. But anyway, that's a cool thing. So if you have an interview question, what's the spectrum of a 20% duty cycle square wave look like? You can draw it out. You can draw it out and see. Hopefully you'll win the job and get a big raise, and things will go good for you. So anyway, once again from the river, this is Dan Bullard. See ya.